Okay, so question 3. The diagram shows the curve y equals the square root of x minus 3. The exciting thing is we can't really integrate that yet in core 2. But by the end of the summer, before you go on your summer holidays, we should have worked out how to integrate that. That would be great, won't it? Something to look forward to. Yes, good. Right, use the trapezium rule with 4 strips, each of width 0.5, to find an approximate value for the area of the region better than the curve, the x-axis, and the line x equals 5. Give your answer correct to 3 significant figures. Right. Now, the way that this works, it's kind of, I've used my hand to with this, but you can also think about a gate, not a gate, a fence around a field. You know how you have fence posts and the fence panels between them? That if we've got 4 strips, that's having 4 gaps, isn't it? And so we need to have 5 x values to fit all the way around them. Does that make sense? Thinking about the edge of a field with a fence around it, you've got 4 fence panels. To hold up 4 fence panels, you need 5 fence posts. You need 1 at the start, 1 at the end, and 1 in between any 2 panels. So we need 5 values for this. So with 5 values between 3 and 5, we're going to use the values 3, 3.5, 4, 4.5 and 5. They are our 5 values. They're the x values. So y is root x minus 3. So if we sub in x equals 3 into that, we get 0. 3 minus 3 is 0, square rooted. Then we've got 3.5 minus 3, square rooted. So square root of a half. 4 minus 3 square rooted gives us 1. 4.5 minus 3 square rooted is 1.5. And 5 minus 3 square rooted is root 2. So there's our values that we're going to plug into the formula. So we put it all together now. The area is approximately equal to a half times h. Now h is the difference between each of our x values we've used here, which is a half. So a half times a half. And then we've got, now just to remind me, I've separated mine into the 2 columns, so I've got the first plus the last, 0 plus 0 plus root 2, plus twice all the others. So twice root 0.5, plus 1, plus root 1.5. And at that point, we just throw that straight into the calculator. And we give our area approximately to 3 significant figures. I got 1.82 when I did this. Four marks? Is that really 4 marks? That's quite nice, isn't it? And then, if they're asking you this, they will probably have given you a diagram to help state with a reason whether this approximation is an underestimate or an overestimate. So what we've done is we've taken this region and we split it up into a series of trapeziums, which would have straight lines at the top of them. So we had a region that's going like that, and the individual areas within that. Oh, I can't draw this on here. That's a straight line. We're going up like that, and we're drawing. Oh no. Do you get the idea? We're drawing. Oh dear. Straight lines across the top. I can't do it. Thanks, Jade. I don't think that'll be any better. But you get the idea. You can draw a diagram to help with it, or what we're going to say. The trapeziums, the tops of the trapeziums will be underneath the curve of the curve. And so that makes it an underestimate, doesn't it? So we're going to say underestimate. And it did say explain with a reason. And the curve, how can we write this? Not the best constructed sentence, but I'm going to write the curve curves over the top of the trapezium. There we go. They would accept a kind of nicely drawn diagram. Obviously, you know, you probably do it with proper paper and pens and stuff. But if you draw a diagram that illustrates that, then that would get the mark as long as you said underestimate. There we go. Happy? So let's move on to the next one. I'll just pause this so I don't have to do any editing.